So this is a demonstration of what's called a transformer. Again, I'll give you a Castify video that will explain the math behind it. But for right now, effectively what we have are two coils. So this is what's called the primary coil. It's the coil that is attached to the power supply. So I happen to have this attached to a DC source, which is a little funky because usually you don't use transformers with DC voltage sources, but that's what I'm doing here. And in fact, you will notice that if I go ahead and bring the voltage, well, actually, let me back up. So this is the secondary coil. Transformers have two coils associated with it, a primary and a secondary. The secondary is going to be attached to the load, which in this particular case happens to be a galvanometer. So if there's any current being transferred or any power being transferred to the secondary coil, you will notice that there will be a current in the galvanometer. It'll show. So notice that if I go ahead and bring up the voltage in the primary coil, which means there's current running in the primary coil, and according to my meter here, apparently there's about 0.3 of an amp flowing through here. Notice that nothing happened in the secondary coil. You got no current. I'm going to bring the voltage back down again, though. And what I'm going to do now is I'm going to go ahead and I'm going to slide the secondary into the primary so that they have a common axis. And so what's going to happen now is the magnetic field that's generated by the primary down the axis is going to end up producing a magnetic flux. And that magnetic flux is going to be common to both the secondary and the primary. So if the magnetic flux changes, you should get an induced EMF in the secondary, which should cause current. And when that happens, you ought to see a current in the galvanometer. So I'm going to go ahead and I'm going to bring the voltage in the primary up. Watch to see what happens in the galvanometer. Okay. So notice that it happened, but now it's not happening anymore. And the reason it's not happening anymore is I just brought the voltage up to 15 volts, but then I stopped, and so the flux stopped changing. It's changing magnetic flux that induces an EMF, which generates a current. So now I'm going to go ahead and bring the current, the voltage in the primary back down again. Watch. Okay. As long as the voltage in the primary is changing, you'll get a changing magnetic field down its axis, which is the same axis as the secondary. You will get a changing magnetic flux, which will induce an EMF in the secondary, which will generate a current in the secondary. So if this had been an AC source, a source where the electric field or the voltage is going back and forth and back and forth, and the electric field is going back and forth and back and forth, and the magnetic field is going back and forth and back and forth, and the magnetic flux is constantly changing, then you would have seen something like this. So what I'm doing here is I'm just changing the voltage. I'm going back and forth and back and forth. And you can see I'm generating AC in the secondary coil. Anyway, that's what transformers do. They basically take power from primary source, and as long as there is a changing magnetic flux, they're able to transfer power into that secondary part of the circuit without actually electrically connecting the two sections. Okay, this secondary coil is not electrically connected to the primary coil. It's connected via this magnetic coupling. And in fact, interestingly, the symbol for a transformer is a coil and a second coil that are not connected electrically, but that have three lines in between that identify a magnetic coupling between the two. And as I said, we'll talk more about this in the screencast that I will be providing you. So that's it.